Go ahead. Did you? Okay. Quadratics. Number 7. I better get started or I'm going to hit the announcements. All right, quadratics number 7 is graphing x squared plus bx plus c. Graphing x squared plus bx plus c. What do you not notice in this that you've noticed in other ones? Is your brain warm enough to go back and think about this? Remember the generic form of the quadratic? What do you not see in this? Or what do you see? How about that? Do you see the B and the C? Let me guide you even more. I'm gonna rush you a little bit. I apologize for that. I'm gonna lead you a little bit down this road. Do you see the B and C? What do you not see? The A, thank you. That's where I'm going with this, right? So in this setup, the A is 1. All right, so there's a 1 here. There is an A there, it's a 1. We're just gonna focus on quadratics that have no lead coefficient here. Going to be a little bit simpler. We'll go back and graph the others in a later lesson, right? That's all I was headed with that, okay, to warm you up a little bit. And then I want to graph 3 quadratics as an example. And let's see if I can map them all out at once. X squared plus 6x minus 27. X squared plus 6x minus 27. X squared minus 14x plus 48. And I want you to get your math app ready on your phone. And I also want to get your Chromebooks ready because we want to go to desmos.com. Remember, nowadays, remember the old days when your algebra teacher said graph? Did you get a break out in a cold sweat? You're like, oh no, right? It's okay, me too. It's like, oh, graphing, this is brutal. Okay, but nowadays, you should be a lot happier. You've got Math App and you've got Desmos. So we're just gonna do typing, all right? So don't worry at all about graphing. We're gonna just figure out from the graph what the quadratic looks like, and we're gonna figure out from the quadratic what the factoring looks like, all right? Rest assured, this will not be as painful as some prior graphings in your life if you've had bad experiences with that. So x squared minus 14x plus, 48. Let me write these right. Did I write this one right? Minus 27 plus 48. And this one is x squared minus 14x plus 45. So here are 3 quadratics. Step 1, I think we should do is, let's go straight to desmos.com. desmos.com. Go straight to that on your Chromebook. And can you type in this first one? Type in the first quadratic, this one here. X squared plus 6x minus 27. And who's got the Math app on their phone? Andre, did you download the Math app? You haven't yet? You got it? Do you think you could point it at this and have it solve it for you? Have it factor it for you and graph it? Who else has got it on a phone? Can you see it from there? You might have to come up and point it at it. Will it let you type in a problem also? Okay, so type it in or just focus on it. Can you see yours from there, Natalie? Natalie's got the best seat for this. Andrea might have a good seat for it. Okay, now, so what do you got? What's the factoring? So x plus 9, x minus 3, it already factors it for us. And scroll down a little, it already graphs it for us. You see how easy that was? But we got to understand a little bit more about it. So we're going to use the tools to look at the solution and then go back through it and discuss how this could be produced by hand, right? First things first, let's talk about factoring. So this factors into 2 binomials that are multiplied together. And this setup of 2 binomials is what we use the FOIL setup. First, outside, inside, last, to then produce this. We're now going backwards and we're factoring it. So this is the equivalent of multiplication is forward. What's the reverse? Yes, division, right? So, hey. So, that's what's happening here. This is being multiplied to produce this. This is being factored or divided, so to speak, a process of dividing to go back to that, right? So we're going forward and backward. And as we do this, we're asking, what two binomials produce this, right? And you already have an answer on your app. What did it fill in there? What did it give you for these two? What's the first binomial? X plus 9. X minus 3. So let's think about this a little bit, right? Because we're kind of going, we've done this before. You can go to the old lessons. You can go the old way and go do the whole FOIL and all that, right? You can go through those. But let's go a little bit quicker here. We've got the trinomial, and we have the two binomials that were multiplied to produce it. If we look at first, and we did x times x, do you see the x squared there? Let's just track through it a little bit, right? First would be the x times x, x squared. And last would be minus 3 times positive 9, or a minus 27. You okay with that? The lead and the tail terms? Have you seen enough of these where you go, okay, those two kind of get set? It's this middle term that is the combined like terms factor that gives our brain a little bit of pause, because it's the combination of, it's the combination of outside and inside. There you go, I gotta get my brain in order. So outside is a negative 3 times x, or a negative 3x. You got that in your mind? Negative 3x, because it's being multiplied out here. You okay with that? Inside is 9 times x. Are you able to take a 9x minus 3x in your mind? Right, we're not even gonna write it down. Just do it in your mind. 9 minus 3 is? Are you saying 6? Be brave. Yes, you know it. Yes, it really is that simple if that's what you're thinking, or it's not a trick or anything like that, right? But there's the x's on it. It's 9x minus 3x, right? So it's not just 6, it's 6x. Fair enough? Does that match up with our middle term? Go like this. Yes, it does, right? So we're basically foiling this in our mind without writing it out. Is this okay? Can you do that? I mean, push your brain to do it, right? Your brain can do a lot of stuff. And probably we don't push our brain enough. Push your brain to expand a little, right? You can do it. So here's the factoring, and now we're looking at the graphing of this thing, right? The interesting thing we talked about the very first lesson in quadratics, number 1, was the zero property rule. It's where we said, if this thing now was placed equal to 0, and is that in our notes? We have f of x equals this, and f of x equals that. If this is placed to 0, then a times b to produce 0, either a is 0, b is 0, or both a and b are 0. Because a 0 times this whole thing would be 0, and this thing times 0 would be 0, and a 0 times a 0 would be 0. I'm saying 0 a lot of times. This is called the zero property of multiplication or something. I'm getting the name wrong probably right now too, but it allows us to pull this out and say x plus 9 equals 0, minus 9 minus 9. The only way for this to equal 0, x would have to be a minus 9. X equals minus 9. So if you put minus 9 here, minus 9 plus 9 is 0. That would make this go to 0, and a 0 times this would be 0. So that's one of your options. This too, x minus 3 equals 0. We would add 3 to both sides. This is the simplest form of equation you can do. X would equal 3. And you could figure this out without doing this simple equation. Just say, what do I have to do? What does x have to be that if I subtract 3, this whole piece is going to go to 0? Well, it would have to be 3, because 3 minus 3 is 0, so x equals 3. So 2 answers. And these are called roots. Everybody say roots. I guess you're thinking of a tree, but it doesn't really help me much. It's just one of those words where this is an x-intercept. So let's do a graph quickly. First of all, what's the sign on the lead term here? What's the sign on this? Positive or negative? Positive, good. So what happens is our parabola or our graph is going to open upwards. Okay. If this were a negative, our parabola would open downwards. And so the first thing we can do is start to map out an x. That's the x-axis. And we can drop a y in. And I don't have to be very accurate at all here. I'm going to get a pretty good picture. Yeah, you're already going like this. That's what's happening. Now we can be more specific. Why? Because x is crossing at -9. So let's say this is -1, 2, 3, 4, 5, 6, 7, 8, 9. Right here is -9. Right? X is crossing at -9. And it's also crossing the x-axis at 3, and that's what roots mean. 1, 2, 3. So we have the parabola going like this through those 2 points already. Then there's some other interesting things here. At the point where x is 0, right? So if x is 0 here, right on the y-axis, if this were 0 and this were 0, we'd be at a -27 on the y. So that's, there's some point down here, -27 on the y. And for the moment, because we haven't covered the lesson yet, I'm going to have you look at your technology. What does it say the vertex is down here? Because we haven't done the vertex yet, so we're going to fudge a little bit as we roll through this lesson. We're going to go a little bit sort of backwards through it. The vertex is the point where the parabola is headed down, the curve flattens out. Does that freak your brain out when we say the curve flattens out? And then it heads up the other way. So think of this. If a curve is headed down, and all of a sudden over here it's headed up, at some point right there, if you drew a line through that curve, it would be perfectly flat. Does that make sense? That's what we mean by the curve flattens out and then it heads back up, right? This is the parabola. Does that make sense? It literally hits a point where if you drew a line through that, called a tangent, right? That line would be flat. And so the curve flattens out, so to speak. It's not really flat at all. It's still always curved. But it gets to a point where it transitions from down to up. So there must be a change in that. And it must happen at some point. That's the vertex in the parabola, right? That's the name of it. So what is, can you tell me the vertex off your graph? -36. Okay. How about, what's its location on the x? Can you give me an x and a y? Yeah, on Desmos it might be easier to see, right? If you click on that point, will it give it a point and give you a location of both x and y? Let's see. It's sometimes a little, let's see. Okay, scroll over, grab it. Nope, grab it, click on it, there you go. Click on it and drag. Click on it and drag. Drag. Well, you got that point. Click on this point. Click right there. Yeah, what's that say? -3, -36. -3, -36. Do you remember plotting points? The x comes first, it's x comma y. So -3, you go 1, 2, 3 to here, and then -36, you drop all the way down. I got a little off here. I don't know where it is. It's somewhere down here, right? This is my point here. -3, -36. And now if I can do some sort of combination here of like this, and this is my vertex, and this, I have done a pretty good hand graphing of the parabola. We'll find this one specifically. There's a formula to find the x, and then we plug it in to find the y. We'll calculate this by hand also, just to prove we can do it, right? You want to use the technology to help you do all this quickly, but you want to know where it's coming from and know that I can go find it. And if you forget it, by the way, you're going to Google, how do I find the vertex of a quadratic? And Google's going to give you the information quickly where you can reread it and figure it back out, right? So I don't know that you have to know how to do this all the time, every time, right? A lot of math you can know. You know, what's that famous quote where a reporter asked Einstein what was the speed of light, and he said, I don't know. And the reporter was incredulous. He's like, how can you not know? You're a genius. And he's like, why should I bother using up my brain with things I could just look up in a book? See, now that's genius. That's a genius answer, right? Why take up my brain power with something I can just look up in a book? So memorization is good for a lot of things, but I see the point, his point is well taken, right? Okay, so if we've done this so far, off topic a little bit, this is a graphing of the parabola. Which way does the parabola open, up or down? And do you see what I mean by open up? So the empty part's up here. Does this one open up or down? I want you to say up. Yeah, why? It's positive. Good. It's positive. In fact, none of these have negatives in front of them. In fact, if you're on Desmos, you could start to play around and start to drop negatives places and watch it flip it, right? We'll do that in a bit, right? Because we've got enough to do right now if I hurry. Let's factor this one. What two numbers times each other equal 48, but add to a negative 14x? Well, what are the factors of 48? How about 6 times 8 is 48? And if they were both negative, a 6 and an 8 would add to 14. So this factored is going to have the x and the x, and that's the beauty of having a 1 for the coefficient here, a, because we know these are x and x. We know it's a negative 6 and a negative 8, because negative 6 times negative 8 is a positive 48. We know that x times x is here at x squared, and we know that negative 6x minus 8x is minus 14x. So we're foiling it very quickly in our mind and just checking that we've got it right? We're zooming through that. If you put it in your app now, you're looking for solving these. What's one of the roots? Do you see that when we put it equal to 0, it flipped? So if x was plus 9, one of the roots was, if x was plus 9 in one of the binomials, one of the roots came out to be, say minus 9. Negative 9. Do you see the sign flipping?
Yeah.
When we moved it to the other? That's what I'm trying to go for. You guys are looking at me like, what are you trying to go for here? Okay, so x minus 3, what's one of the roots going to be? You want to say plus 3. X is going to cross at plus 3, right? What's one of the roots? Plus 6. What's another one? Plus 8. I'm going to spread them out here. I'm trying to make my scale a little bit. We know this thing crosses like this. We know it goes like this. If we figure out where it crosses the y, and this is a little bit more difficult, and there's a separate lesson on this, if we plugged in 0 for the x and 0 for this x, so zeros here, these would disappear. We were left with minus 27. That's what it crossed. If you plug in 0 and 0, where's it going to cross the y? This goes to 0, this goes to 0. Where's it cross the y? So way up here somewhere. It's going to cross the y. Now what I don't know right now is my vertex yet. And I kind of want you to plug it in. Take a picture of it, Natalie. Did you take a picture of this one? Go new. And tell me what the vertex is. And I'm kind of rushing you through in a summary of graphing, right? Just so you can see sort of a big picture. Yes, I can plug it into Desmos. Yes, I can use the math app on my phone. So look for, click down there. No. Oh, maybe, scroll up. Click, scroll up. I want to see that, I want to see the vertex. No, the other way. When I say scroll up, I've got the wrong way. There. Click right where it changes direction. Yeah. Does it tell you what that point is? 7, negative 1. See it right there, Natalie? Look, see it down there? 7, negative 1. So here I am out at 7 and negative 1. So 7, negative 1 here. Look at how shallow this one is. But it goes through these points. Now I can go like this, kind of. Let's see if I can get it sort of right. Fair enough? Okay, not bad, and you can look at your app and correct it. And very quickly, roll to the next one. What times what is 45? 5 times 9. And 5 plus 9 is? Because this one's negative and this one's positive, it has to be x minus 5, x minus 9. These have to be negative to combine to that 14. And these have to multiply to change into the positive. Do you see how you can do FOIL quickly in your mind, where now you don't have to draw out all the arrows or all that stuff? If you can remember FOIL, just kind of start to piece it together. Where is it going to cross the x-axis? Good. Plus 5. Everybody say plus 5. And do you see why? Because we're putting that equal to 0, so technically speaking, this must be 0 and this is 0, and I better be a little bit cautious about that, just so that forces us to go through that zero property rule. And technically speaking, that means this equal to 0, and this equal to 0, and this equal to 0 here too. Let me try to be a little bit more diligent about that facts here, okay? And that's why this gets put equal to 0. That's why it gets switched to the other side. X must be 5 minus 5 to produce a 0. So one of the roots is going to be 5. What's the other root? Plus 9. So here we are. 5, 9. Here and here. Those are roots. What's another word for roots? X-intercepts. What's another name for roots? Zeros. At least 3 names. X-intercepts, roots, and zeros. Why zeros? Because it's the zero property rule that allows us to switch those out and find out what they have to be to produce a 0 there, right? Roots, I don't know why we call them that. Somebody else knows. Okay. Where does it cross the y-axis? Put in a 0 and a 0 for the x. What do you get? So somewhere way up here at 45. And help me shoot it with help me with the vertex. 5, 6, 7, 8, 9. So somewhere in here, 7. And -4. So 7 out, 4 down because we do the x, then the y. So 7, comma, -4. And it's going like this. Ready? And that's what shape? What is this called? What's it called? Everybody say parabola. Say parabola. Now, I like to say parabola. But don't say that to your next teacher, okay? Because they're going to think I taught you wrong. It's not parabola. It's parabola. But that's how you spell it. Like, my brain can't remember how to spell. So my brain's always like parabola, okay? Parabola. Everybody say parabola. Okay, now forget that. Say parabola. All right, there you go. First, I would teach you wrong. Then I would teach you correctly. Okay, so that's the graph in a nutshell. That's graphing of a parabola, which is coming from a quadratic equation. And the interesting thing is that it's this square. That's what makes this a quadratic. And the idea that it comes from 4 multiplication steps to produce it.